All right, welcome back, everybody. Let's continue on our journey of exploring the graphs of the trig functions. We've done sine and cosine in fair depth. 6.5 is on the tangent and cotangent functions. And let's start with y equals tan x. Keeping in mind that tangent x is sine x over cosine x. Which means tangent x has issues. There's problems anywhere cosine equals 0. And if we think of our unit circle. Any point on the circle is cosine theta, sine theta. So we're looking at the x value. When is x equals 0? Along the y-axis, so x equals 0 when theta equals pi over 2, 3 pi over 2, 5 pi over 2. We can do negative going the other direction, negative pi over 2. It's along here. So it's kind of like pi over 2 plus n pi. Which I think is the easier way to kind of remember it. You have the pi over 2 and you're just adding multiples of pi. Another way of writing that is you get a common denominator. And you have 2n plus 1 times pi over 2. When this happens at these points, or at these angles, and theta is going to be our x. So when x equals these values, we are going to have 0 on bottom, which means we have a vertical asymptote. Mark the pi is going to be easier. My vertical asymptotes are at pi over 2. And every pi onto that. I'm going to have a vertical asymptote at all of these. And when we think about what we have. Like, let's look at one range, let's look at like the negative pi over two to pi over two. Cause if we can get this range down, it'll repeat. So when we stick in zero, we have sine of zero over cosine zero, which is 0/1, we have a 0. And then the only other ones that are really easy to mark are the pi over 4 lines. And that pi over 4, 45 degrees, sine and cosine have the same value. And so sine over cosine is 1. And negative pi over 4, sine is negative, but cosine is positive, so you get a -1 for negative pi over 4. Now, it makes it look like it's going along in a straight line, but the asymptotes fuck it up. So what we have is something that looks a shitload like x cubed. Except it follows an asymptote. So it looks like x cubed, but. But it's an asymptote. And that behavior repeats. So what you need to remember for tangent is x and y equals 10x, make a little table. We're gonna do increments of pi over 4, starting at negative pi over 2. With the top of these both being undefined, so they're asymptotes. That's a 0, and we go -1, 0, and 1. What does the period look like here? How often does it repeat? Period repeats every 5, doesn't it? Our x-intercepts or zeros occur at multiples of pi, so n pi. Since there's no maximum or minimum value, because near the asymptotes it shoots to positive infinity or negative infinity, there's no amplitude. Because there's no maximum and minimum. Tangent is an odd function. Which means tangent of negative x equals negative tangent of x. And we see that with the pi over 4s. I mean, we could do more values, but we don't need more values. If I stick in negative pi over 4, the negative pi over 4 becomes positive pi over 4. So tangent of pi over 4 would be 1. But tangent of negative pi over 4 is negative 1, so the negative sign's up. The domain is kind of a little wonky to say. It's kind of like all x except x cannot equal pi over 2 plus n pi. Can exist, but you know, it's got a lot of gaps, a lot of holes. But the range is infinite. Negative infinity to infinity. Alright, so. About a couple of words still writing and wait. Kind of sucks. I've noticed that you guys and my Calc 2 class. The chapter lengths are approximately about the same. So testing occurs at around the same time. So I'm getting like a stack of motherfucking tests on the test week. That sucks. Alright. Next one, cotangent. Y equals cotangent x, or that's cosine over sine. So we will have asymptotes. Where sine x equals 0. And thinking back to our unit circle, that happens at 0, pi, 2 pi, 3 pi, 4 pi. This happens at x equals n pi. So these are cotangents, asymptotes. And tangents are similar, as I recall. They're just off by pi over 2. You just gotta keep that in mind, they're similar, but. Slightly off. So we'll say that's our domain. Domain is x cannot equal n pi. And we're gonna see that the range is like cotangent infinite. Probably easier to mark the pi over 2's now rather than the pi's. Because the asymptotes are gonna go along with pi's. And then let's look at the pi over 4 marks around the pi over 2. Cause we know stuff happened for tangent there, and we know tangent and cotangent just flipped over. So there should be some connection there. If I stick in pi over 2, I have sine of pi over 2 on bottom, which is 1. Cosine of pi over 2 on top, which is 0. 0 over 1 is 0. That's gonna give us that. Cosine of pi over 4 and sine of pi over 4, those are both the root 2 over 2. Which means pi over 4 is gonna be 1, just like tangent was 1 there. If we do cosine of 3 pi over 4. They're both root 2 over 2, but cosine is negative in that second quadrant. So we're gonna have a -1 here. So this kind of looks like tangent, like. Flipped sideways and moved over a little bit. And we'll see that behavior repeating. For all tangents, for all cotangents. It's like our x-intercepts. Or zeros. Occur at pi over 2 and then every pi. So plus n pi. That's cotangent. Whereas tangent had the x-intercepts at n pi. So you'll notice that the asymptotes and the zeros just swap values between the two. Like tangents asymptotes are cotangent zeros. And cotangents asymptotes are tangent zeros. Period here is again pi. Again, there's no max and no min, so there's no amplitude. We don't have it doesn't follow a wave-like form like sine and cosine do. And just like cotangent is 1/tangent, tangent was odd. So cotangent should be odd also. Cotangent of negative x equals negative cotangent of x. Tangent is an odd function. Why I keep saying this odd and even function, why do we care about odd and even function? Let me give you a little flavor from what's gonna happen in calculus. In calculus, you're gonna look at area under the curve. So an even function like y equals x squared. If I go from negative a to a. This area is the same as this area. So rather than doing negative a to a, we can do 0 to a times t. For every even function, as long as you're doing this. And it becomes useful in calculus, it makes doing stuff easier. Anytime you can plug in 0 rather than a number. The math is so much easier when 0 is a fucking option. And when you have an odd function like y equals x. And we do negative a to a. Again, the red side is the same as the blue side. But they offset each other. Until you start treating things as positive, you can do a signed area. But until it's like done that way, they kind of offset. So on an odd functions, these offset. You get 0. Which is handy. So having an odd or even function becomes useful, and that's why we're bringing it up. That's just a flavor of where you're going, I haven't even covered it yet in calculus, so it's like, I think in chapter 3 or 4. No, it's gotta be chapter 5, we don't do area till later on. Yeah, do derivatives first. But it gets there, that's why we do it. You guys ready for more? Some folks aren't. I see things still coming. So, graphing. Graphing, y equals a tangent of bx or y equals a cotangent of bx. Assuming b is greater than 0. If it's not, if b is negative, we put the negative out front, because these are odd functions. You can make it positive. Putting the negative out front. Or I'll say on A. Because they are both odd. It's a long time for someone taught me like what odd even were for, and so I ignored it while I was being taught it, like, who gives a fuck? I'm just gonna graph it the way it is anyways, it doesn't seem important, but. Then I'm like, oh shit, what was odd, what was even? Once I understood about it. Alright, so with b greater than 0, step 1, find the period, of course. And just like we did with sine and cosine, we take our period and divide by b. The other way of doing it that some folks liked was having this. And then dividing by b there, or multiplying by 1/b. On everything. And so it looks like negative pi over 2b. Is less than or equal to x, which is less than or equal to pi over 2b. That's tangent. This is tangent's options. Cotangent does something similar, but we went from 0 to pi. So when we divide by b, we get 0 is less than or equal to I, or x, which is less than or equal to pi over b. These values for each of those functions are your vertical asymptotes. And repeats every pi over b. From the period. So step 2 is sketching them, sketch the asymptotes. Because that really guides how the behavior is. Sketch the asymptotes. You can see on tangent, we divided it up into 4 parts, like part A, B, C, and D. So divide each region up into 4 parts. So just like sine and cosine, we have 5 total values we care about. You have your 2 from your asymptotes. And the 3 dividers. Because if you need 4 regions, you only need 3 lines to divide it into 4. Pi over 4, 0, and pi over 4 was what we had. You're just gonna take your thing and chop it just like we did with sine and cosine. Cut it in half, cut each of those in half again, and you've got your 4 parts. It's like we did here. Halfway point and then halfway point of each of those. Then draw the graph. You can do it by evaluating points at the dividers. Until you're comfortable and you go faster. Everywhere cotangent was. Everywhere. Tangent x and cotangent x. Was -1 or 1. That gets changed to -a or a. Because we have an a up front and we're multiplying by it.
So it's all the same.
I see you back, Keith.
Oh yeah, I got my phone working. So
Good. All right, you guys ready? For some examples. Now that we went through all the boring shit. The rules. Y equals tangent of 2/3 x. So our period is gonna be. Pi over 2/3. Which is the same thing as 3/2 pi. If you multiply by the reciprocal on top and bottom on 2/3, 3/2 on top and bottom. Bottom goes to 1, and then you're left with 3/2 pi. I really think doing the -pi/2 to pi/2 is really helpful on this one. Cause like going, how does this help me divide up my tangent? Not really as useful. But if I do that is 2/3 x. And pi/2. I can figure out what I need, but it looks like I need to multiply by 3/2. To cancel that out, so we'll multiply by 3/2 on all of them. And it looks like we're going from -3 pi/4 to pi over, or 3 pi over 4. So since my asymptotes are in terms of pi over 4. I'm gonna rewrite this in terms of a denominator of 4 also. If I multiply by 2 over 2, I have 6 pi over 4. That's gonna make it a little bit easier for me to do the repetitions on tangent. Alright. And if I add 6 pi over 4 to that, I have 9 pi over 4. If I went the other way, I would have negative 9 pi over 4. That'll give me my asymptotes to put in. Yeah. Cause I'm adding 6 pi over 4 to 9 pi over, or 3 pi over 4. It's gonna repeat every 6 pi over 4. Does everyone go with that? It was, you weren't here for tangent, tangent's every pi. So this is now with our modifications every 2 pi over 2. It just gets repeated more often than sine cosine. Alright, so all of these would get broken down into four departments or 3 dividers. This divider is fairly easy at 0. If I'm going halfway between 0 and 3 pi over 4, I just multiply 3 pi over 4 by 1/2. And I'll get the halfway point, 3 pi over 8. Now I'm gonna do it just to show you how to do it, but you're gonna get used to not doing it. What we're doing is we're taking each of those values and sticking them in. If I multiply this by 3 pi over 8. What do I get? I get tangent. What does that reduce down to? The 3's cancel. The 2 cancels with part of that, I get pi over 4. That should happen every time. Unless we're shifted, somewhat. But tangent of pi over 4 is at the 1 and -1. So we should still have. Until we do phase shifts and stuff like that. Should be like that. And we're doing this. Now we get it repeated over here and down there. You can do the same thing with the negative 3 pi over 8. Should get tangent of negative pi over 4. Oh, you can tell I sketched that by hand. That looks terrible. But the idea is there. This one's all super wide and this one's all narrow. It doesn't even like that. That doesn't even look vertical. It's all skew. But that's an acceptable graph. You have something like this like on the test, it's good. Any questions? Are you guys ready to try one? We're gonna get you guys started on -1/2 tangent 2x. Give you guys a few minutes to do this and we'll do it together.
I had a quick question, Professor Jones.
Yeah,
Do you want us to would would it be okay if we just had two sections, or did you want us to have like all four sections of tangent thrown out?
you should have at least two. What do you mean all four sections?
Okay, okay, all right.
Well, wait, what do you mean all four sections? Cause I looked up on my graph, I've only got 3 graphs there. Are you talking about this, and this?
I'm talking about from 9 pi/4 to -9 pi/4.
You should have something in the center and then the 2 quarter mark and 3/4 mark.
Oh, okay, okay.
Because that's where the the A in front shows up. You should have all 3.
Yes. Thank you.
So what's my period?
Pi over 2.
Over 2. And what does my range here end up being? Say that again?
Sorry, negative pi over 4 to pi over 4.
There we go. You'll notice I never keep the spacing the same from page to page on the graph, because if I try to do this in like pi over 4 on the same scale that we had pi over 4 on the last page. This window get like pi over 4 would be right here, and trying to do all of tangent in there is just ridiculous. So you kind of make your x-axis scale to where you have some reasonable room to work. So that's gonna be pi over 4. And negative pi over 4. As long as you kind of like write those two, it tells me what the spacing is. Then we can throw in our asymptotes. You don't need to label the rest if you've got those two labeled. And you use like equal spacing on the rest, it should be clear from then on what's going on. If I cut this into thirds, what are my values in the middle? Pi over 8. Oh, and I drew this the way I wanted to draw this. Normally with tangent in mind, but I got that multiplier of negative 1/2, which is gonna. What's the negative 1/2 gonna do? It'll shorten it. But what else is it gonna do? Let's take a look at negative 1/2 tangent of 2 times pi over 8. So we're doing it pi over 8. So y equals negative 1/2 tangent of pi over 4. Tangent of pi over 4 is 1, so this is negative 1/2. So pi over 8, we're going down to negative 1/2. So the negative, let's flip the graph over. I did the same thing with sine and cosine. It kind of looks like it's doing sideways. It should look something similar to that. If I could do that a little bit better. We'll say I hit it. So that's what we should be having. We can verify the negative pi over 8 is positive 1/2. It's negative 1/2 times negative 1, which is 1/2, so it should be up above on the left side. Got that was bad. A little more like that. Take a 10-minute break. I don't want to overwork you guys. Pause the video for a few seconds. Now let's throw a cotangent at you. Y equals 3 cotangent of 1/2 x. And remember, the base range on cotangent is 0 to pi, not negative pi over 2 to pi over 2. So that's what you're altering. What does that leave my period to be? So these should be fairly easy to break up. We know that's pi. Pi over 2 and 3 pi over 2, just like our unit circle. Since it looks like 3 is gonna be a number. That's important. What happens at the middle of the graph? What's happened on the middle of the graph for all of these so far? 0. Tangent and cotangent, the middle was 0. So if you don't remember which way it goes, is it up on the left or up on the right? Just plug in one of the values. I'll do the pi over 2, so if we do plug in pi over 2. I've got 1/2 times pi over 2. 3 of cotangent pi over 4. And I don't know about you, but I suck at remembering what that means. So I'm gonna do that as cosine of pi over 4 over sine of pi over 4, because I know those values. And then, just like they were up here, pi over 4, when they're both pi over 4, that is 1. So this should give me a value of 3 at pi over 2. So this is the one that's left on, upwards on the left, which means it's downwards on the right. What, Jordan?
I think I saw it plug in. Probably two.
You can do that, let's do it. If you don't like what I did, let's do it. Plug in 3 pi over 2. And we get 3, I'm gonna write it in cosine and sine right away, 3 pi over 4 over sine of 3 pi over 4. These are also root 2 over 2, but cosine is negative there. So that goes to -1 times 3 is -3. If I've got my ruler right, we'll just pretend like it didn't. A couple left, things left to discuss in tangent and cotangent, we'll get out, we've done early today. What do vertical shifts do and what do phase shifts do? Y equals -3 plus tangent x. So the tangent x part hasn't changed, if you wanna draw the base graph, pencil it in lightly. That's what I'm gonna do. Asymptotes are not changing. And we did our little set points in between there of pi over 4 and. Negative pi over 4. The base graph of tangent kind of looked a little bit like x cubed. Doing that. I'll just sketch in one of the base graphs, that way. When I put the final graph in, I won't have a bunch of pencil marks everywhere. What does the -3 do? The what? Down. So wherever tangent was 0, it's now -3. Does that make sense? So where tangent was 0, we're gonna go down to -3. That's my 0. And the easiest way to go from there is, we know we're going up 1 on the right and down 1 on the left. And that'll be our tangent. And that'll get repeated. Have you seen a couple of them? You've seen them all. Or no, we're gonna do one right now, and then we'll be done. We'll be done in like 10 minutes. We're not ready to throw cosecant and secant at you, that'll be Monday. Or Wednesday, right? We're on Monday, Wednesday, flat, right? I never know what day it is anymore. Yeah, we'll do that on Monday. Surprisingly, not that bad, it's just like sine and cosine, we're gonna do variants of that. In fact, we built the sine and cosine graph to make cosecant see it. Let's take a look at, in fact, I'll do it on another page. Make sure we got room, I don't wanna, crowd us. Just like we did without the phase shift. Just put it all together, 3 plus cotangent of x plus pi over 2. So the phase shift, unless there's a b, what's b here actually?
1.
B is 1, so our period is still pi, right? All we're doing is shifting where that is. The base graph for cotangent was 0 to pi. So we're gonna take what we have as our argument to cotangent and do that. And see what it shifts to. So we solve this and. All of a sudden, our asymptotes look like. The same asymptotes as tangent. If this was 3x plus pi over 4 in there, we'd do the same thing. and solve to get where our asymptotes are. And we would use here, the period would be 3. Or pi over 3, because we got the 3 right there. And we would use this to set up our base asymptotes and do pi over 3 from A. That's like if I had 3x plus pi over 4 in there. So we've got our asymptotes, we'll put them in. Wait. It looks like I'm moving up 3. So I'm gonna give myself more room. We said we want pi over 2. And negative pi over 2. Our base graph of cotangent. I need to put in my y values here. So we'll have pi over 4 there and negative pi over 4 there. It was up on the left and down on the right. And 0 in the middle. So our base graph looked like that. The plus 3 just moves those all up 3. And then we'll do that 3x plus pi over 4 real quick. That's like the full package, right? So I'm gonna do, set that up here, I'm gonna do y equals -1 plus cotangent. 3x plus pi over 4. So our period is gonna be the pi over 3. We're dividing by b. We'll set up our interval. We'll subtract pi over 4 from all the spots. Pi minus pi over 4 is gonna give us 3 pi over 4. And then I'll multiply by 1/3. And since the left one is gonna have a 12 on bottom. I'm not gonna cancel out the 3 on the right, I'm gonna keep a 12 on bottom for both. I think that's gonna be a little bit easier to draw everything. So it'll give me negative pi over 12 on the left. And 3 pi over 12 on the right. And if I look at the period in the same terms with the 12 on bottom, I need to multiply by 4 over 4. This is 4 pi over 12 and that fits, that makes sense. So my little markers are pi over 12 steps. That'll be 3 pi over 12, and this will be negative pi over 12. And that has conveniently broken up our range into 4 values already. I'll extend it a little bit. So cotangent normally is 0 in the middle. And is it up on the left or up on the right? It's up on the left. So the base graph looks like that. And it looks like we're shifting it down -1. So all those points are gonna come down 1. And we have something like that. So if I repeat that over here. And there we go. Any question? All right, you can get the fuck out of here. Well done.
Have a good one.
Yeah, what's up, Pete?
Oh no. Oh, have a good one.
You too.